Good morning, good afternoon, good evening to the people around the world. This is Martin Hubel, your host of the DB2 Night Show. I'm now doing both the LUW and the COS versions of the show, and I look forward to interacting more with the LUW audience. However, I also have presented so many times for DB2 LUW that I'm sure people know me. Today I've got a very special guest with me, Greg Stager of the IBM Toronto Lab, and he'll be speaking with us on the light at the end of the encrypted tunnel. How are you doing today, Greg?
I'm doing very good, Martin. How are you?
Great. Yeah.
Great.
Well, we're doing good. We're getting back into fall weather up here, I'm afraid.
Yes, that's right. It's still nice, though.
Yeah, you don't have to shovel it. That'll come soon enough. Then I start putting up my Canadian humor jokes in the middle of the snowstorms and stuff like that.
Well, I'll appreciate them.
Well, ironically, last year I put up one about somebody who'd left their lawnmower out and it had been totally covered over with snow. And then 3 days after I put that slide up, I put up a slide of my front lawn or my front yard where you could not see the snowblower except for the handle because the snow would keep out there. So I hate it when life imitates art.
That's right.
Okay, let's move along and flip some slides here. And once again, here's our famous Get Involved slide talking about Twitter. If you follow hashtag DB2Night, you'll get updates on when the next shows are. I promise to be much better this year at doing that. In the past, sometimes I haven't updated Twitter as often as I should. We also have a LinkedIn group, the DB2 Night Show, and you can join that, and the registration information is there. We encourage a back and forth on the format of the show and other presenters and things like that. So we look forward to having you contribute with us. Here's our famous disclaimer. I could read this, but I think you can read it for yourself. Basically, it says things are copyrighted and being recorded, and we're all going to be nice people while we do this, and it's copyright 2019 DBI. And then we'll go through some quick announcements. We've got to talk about the new schedule coming up for the fall, and we'll do some polls, and then we'll have the presentation. So here's our schedule as it looks now. We have all of the LUW shows the speakers are booked. The only thing I'm waiting on is George Backlars's topic. I didn't bug him about it too much because it's 3 months off, so I'll get that done by next month. Next month, we're going to have a newcomer to the DB2 Night Show. I thought John would have presented here before, John Hornibrook, because he's a veteran presenter from the IBM lab on DB2 Automatic Statistics Deep Dive. And we've got Ember Crooks returning in November. And she'll be talking about how to evaluate the health of the DB2 database. And Ember, as you know, always does a great job. On the Z side, if you're bilingual like I am, we have Roy Boxwell kicking off in 2 weeks the presentation on DB2 for Z limits. And then we've got a presentation on agile development for DB2 on Z, which should be fantastic. Patrick knows an awful lot about that and does a great job. And Adrian is coming back in November, Adrian Burke, to talk about distributed best practices for DB2 today and tomorrow. And on the 20th, once again, it's 3 months out. I've got a couple of people I've just got to confirm, and I'll announce that on the next show. So we're doing well in terms of having a really great, strong program for the fall, and I've also had some people that couldn't present in the fall, but are looking forward to speaking in the spring. So we'll also have a great shows for you then as well. As always, we do a little bit of marketing for DBI. Just to remind you, if you're interested, there's a demo online. Register for it, and you'll get a free $15 gift card. And that's a good way to see what's going on with the DBI software. They've made a whole bunch of improvements, and it's really great stuff. And here are our sponsors for the DB2 Night Show. DBI and myself, Martin Hubel Consulting, yours truly and all that. And now we're into the polls. I'm trying to move along because Greg tells me he has 90 slides, of which he'd like to do 50. And if we're going to get those done, you've got to get me out of the way first. So now we get to the polls. And we click this, click that, select a poll. And here's our first question, as always. What DB2 LUW versions are you running? I've had to update this, of course, because 11.5 is out now. And that's really cool stuff. It's becoming a lot easier, particularly for guys like me that like to install DB2 on my various devices, my laptop and on various desktops. So 11.5 is a lot easier to do. The licensing has been greatly simplified. So we've got about 70% of our audience have voted. I'll close that off and share that we've got 15% of our audience on 11.5. Most people seem to be on 11.1 and 10.5. You get to have more than one vote here. And we have nobody on the old stuff, and that's a really good thing. Okay.
Yeah, that's great to see.
Well, for years, and I think only about 2 years ago did I actually stop working on 8.2.2 for a customer.
Right.
Well,
yeah,
they
it
had
sticks around.
The problem was WebSphere Commerce. It was another IBM piece of software that did not support anything newer. Sorry, let me put it this way. They would have had to do major changes to their application to be supported. They would have had to put in a new version of WebSphere Commerce as well as DB2, so they were reluctant to do that. So here's just a little question I made up. Greg, I hope this is interesting to see. And I'm asking whether or not where people encrypt data, whether they do it on databases and the network, or on one or the other. And this is interesting.
Yeah, at rest or in transit, another way of putting it.
Yes, I said in databases and on the network because the other stuff sounds cool to say, but I've learned through the years that sometimes things that sound really cool to say are less meaningful when you're trying to have a conversation. I used to go to IBM presentations, and the guy would not say, "What you will see on the screen." He goes, "You'll see this on the glass," and they like to say glass for a while. And I'm going, well, that's helpful, or not.
I'm not familiar with that one, so
there's some old one. There's some older ones. People trying to be cool, and they used to talk about having a monkey on your back as having the problem, right? And somebody turned that into having the Megillah, referring to a 1960s cartoon, which was Megillah Gorilla. And but trying to have a non-English speaking audience understand that was less than fun. Less than fun. So,
anyways, the results there were interesting, and I think a good topic for today. That the majority of people are using encryption for in transit.
Yes.
Over the network.
Yeah.
Yep.
The idea and the additional considerations of actually having data encrypted in a database. And I have one customer in particular that has sensitive data from multiple customers residing around, and we're concerned at some point they're going to have an auditor want to come in there and make sure that their data is encrypted both in transit and at rest. So here we're getting the votes to your question there. I had to shorten one that
Sure.
had the certificate signing request. Yeah, but I GoToWebinar only gives me so many characters. So, but we're getting some good answers on this. People are thinking about this a little longer. We're getting fewer votes. I guess the other thing I said that we could have put there is we don't use SSL/don't know, because some people might not know. But anyway, let's close that off and see the results on this one. And we notice that we have the gamut here in terms of...
Okay, yeah.
And by the way, what does CA mean to you in terms of an acronym there?
It's certificate authority, and slide 4 or 5 or something gets into what that is specifically. So
yeah, and SSL is secure socket layer.
Yes.
I did mean to explain those, but there's our results. And you notice we another gamut of things there. That's great. All right.
Yeah. And those are going to help me know what to talk a little bit about, which slides I can go faster on or slower on.
Absolutely. And we also just like to allow people to give us some information so we can do exactly that and gear the talk to what you need, what you want to tell people. With that, you should be seeing my screen again. I'm going to go forward here and show the one non-DB2. Actually, this is an IBM slide. I often show this little guy on the ZOS show because this is Charlie. He's my silent partner in running these shows. And that he's a rescue toy poodle. We've had him now for nearly 10 years. And that picture in the middle does have IBM content because the bone I'm holding for Charlie to chew on came from the school when we had the DB2 SAP Technical Leadership Exchange have dinner there. And Li Wen Yao of IBM passed that bone on for Charlie, and I wanted to show evidence of Charlie enjoying a meal at IBM's expense.
Very cute.
And he does still weigh 8.5 pounds. And there we got him on the right side, dressed for winter. Don't know if I'm going to make him go through that again this year. He's at the age of 14.5. He's showing less interest in getting dressed up.
Yeah.
But he's still a cute little guy. I've also found that the doggy coats really don't do that much. They're more for the owner. The boots are the important part, and he hates those. Okay.
Yes.
Now we'll turn it over to you, and let me get my screen up here where I can click you and make you the presenter, and you should see that little message. And I don't know why we got Paul Bird's wonderful picture there. I'll have to go in and repair that at some point, but now I am seeing your screen, so please take it away. By the way, just to let you know, there is a question and answer tool. And we don't have any questions at this time, but the audience knows, or our veteran audience members know that they can type a question into the tool. I'll see the question, and I'll interrupt you at an appropriate point to ask the question. So if anything comes up, I'll do that as well. Just to let people know as well, Greg will be making his slides available, and we'll put that on the replay blog along with the recording. Okay.
Great. Well, thank you very much, Martin. So my name is Greg Staker. I'm the DB2 Security Architect here at the IBM Toronto Lab, and going to talk today about TLS or SSL. And the title of my talk is Light at the End of the Encrypted Tunnel, and it's really about giving people hope that they can use SSL successfully. That we get a lot of questions here in the lab about how to set it up, and that's what we're going to go through today is how to use it. So some of the agenda items we have, just learn the fundamental principles of TLS and certificates, learn where DB2 uses it, how to configure it, and then some of the operational aspects of working with it. So what is TLS? It is Transport Layer Security. And you'll also hear the term Secure Socket Layer, SSL. They are used interchangeably. TLS is the official standard, but it was originally named SSL. They're both used equivalently. TLS provides communication security, so encryption and authentication, so that is data in transit over the network. It sits on top of TCP/IP. Other uses there's such as UDP as well. You'll often have seen it. Everybody's used SSL. It's the S in well-known protocols like HTTPS. When you go to your bank's website, you get that little green lock in the left corner. That is saying that TLS is in use. It was originally developed by Netscape way back in 1995 and has been continuously enhanced since then and is now an open standard. So just a little history about some of the versions of TLS. So TLS 1.0, when it became an official internet standard, was back in 1999. Version 1.0, 1.1. These are still supported in DB2, but they are considered insecure, have known vulnerabilities, and I suggest that you do not use them. They are slowly being removed from various products. TLS 1.2 is the current standard, considered secure, supported in DB2 since various fix packs you can see here listed. It is unfortunately not the default and must be configured. So that's something just to be aware, and we're going to get into the details of how to do that, but just remember you want to be using TLS 1.2 right now. TLS 1.3 was just ratified as a standard last year. Took a while to get the final approval for it from sort of the Internet Standards Body. It improves on 1.2. It addresses a number of theoretical weaknesses that it has, but as of right now, 1.2 is still secure. So we're only starting to see applications like web browsers move to it. DB2 does not support it yet. It's likely sometime in the future as the industry moves towards that, but TLS 1.2 is sort of the gold standard at the moment. So to get into a little bit about how does all of the TLS and certificates work, we're going to start with some very basic cryptography concepts, and that is the use of public key or asymmetric cryptography. And asymmetric meaning a different key is used to encrypt and decrypt. You may have heard of symmetric cryptography like AES, where the same key is used in both cases. This is a little different. So we have, I'm using the official term here, fancy math, creates a linked public and private key pair. And as the name suggests, you have two keys. One you keep private, that's a secret. The other you make public. You want everybody to know it. Okay, and the fancy math is based on sort of prime factorizations. That's RSA. There's other uses, elliptic curves, that sort of thing. But that math creates two keys that are linked in a very special way. And that is what you encrypt with one key of that pair, you can only decrypt with the other. And this is the foundational concept of certificates and TLS and public key cryptography. So we have one key, it does one thing, and you need the opposing key to do the other operation. So you encrypt with one of them, whichever one it is, and you have to decrypt with the other. So if you encrypted something with your private key, that private key cannot decrypt it again. It was encrypted with it, only the public key in this case can decrypt it. So it's a foundational principle for what we're going to see going forward. Once we understand that the two keys are involved in encryption, it leads us to the next concept we need to understand, which is a signature, a digital signature. And what that is, signing something says we take a hash of a message, whether it's an email or in this case a certificate, and we hash that and then we encrypt it with the private key. We don't bother encrypting the whole message with the private key. That can be a bit slow, and generally we want everybody to see the message in the case of certificates. So we just take a signature at the end. We take a hash and then we encrypt that hash with our private key. Because why do we use our private key? We want everybody to be able to validate the signature. And that means they're going to need to use the public key to do that validation. Okay, so the public key will decrypt it, you'll recompute the hash, see that they match, and go, okay, great, the person with that private key is the one who signed this message. Then that leads you to a question. Well, how do we know we have the correct public key, right? So I use the public key to check that signature. How did I know I have the right one? You may have seen things like SSH, where you're copying your public key onto the server into a specific directory. So every server you want access, you have to copy that public key. That's one method. PGP has a concept of web of trust. So these are just some existing ways of sort of publicizing that public key. That leads us to, though, certificates. So what is a certificate? At the basic level, it is a public key and associated metadata that has been signed. So again, it's someone's public key and then some metadata saying their common name, or their organization, a number of values like that. The public key, that metadata gets signed by someone, and that becomes a certificate. So who signed it? Well, technically anybody can, but it's really only useful if it's someone you trust, okay? Because what it's saying is the issuer, the person signing it, is attesting to the identity of the certificate holder, saying, I signed this because I did some checking before I gave them the certificate, before I signed it. So on the right-hand side, we kind of see an example here, which is DigiCert having issued the certificate. They created it. They gave it to IBM. Okay, so this is just, you can go to IBM's website and find this certificate there. This is sort of like, it's public knowledge, right? And it is saying that DigiCert validated, whoever went to them to get the certificate, validated that they worked for IBM, that they were authorized to issue certificates for them, okay? So that's how we trust these companies, is because they're doing this background work. How do certificates help us? Well, it reduces the complexity of the key distribution problem. So you only need to broadly distribute the issuer's public key. This is the root CA certificate. You have one thing that you have to get out there to everybody. And then when you get a new certificate you've never seen before, you validated that it's signed by that trusted issuer, that root CA, that one thing you had to distribute, and now you know you can trust the contents of it. Okay, so instead of, like we talked about before with SSH, every user having to copy their public key to every single server, right? That's a big headache. If you want to email people, you would have to exchange keys with every single person you wanted to email. You don't have to do this. You distribute a single trusted certificate that says, I trust this person to sign things, and then that sort of problem goes away, because you now have the ability to validate things you've never seen before by checking that they've been signed by that root CA certificate. The certificates can come in a hierarchical or tree-like nature. You can have A, sign B, sign C. The very top level of the tree is called the root certificate. Then there are intermediate root certificates. And finally, the last one in the tree is called an endpoint or end identity certificate. There's other names like personal certificate. That's for an individual user or for an individual server. And if you've ever heard the term public key infrastructure, that is sort of the whole management of certificates and binding with identity. That's sort of the whole process of how this all works together. So, Martin, you asked me at the very beginning, what does CA stand for? It was later than slide 5, it's slide 10, but great. It is Certificate Authority.
Yes.
And this is a formal organization that issues certificates. That's their job, that's their business model. Okay, these are the companies that are doing that validation. And that's why they exist, because they are, they're either checking your driver's license, or you're getting tax documents, or, very complex things depending on what level of certificate you're trying to get.
Right.
So there's different types. There's two types. There's public companies. So examples are DigiCert, Let's Encrypt, Komodo, GeoTrust, GeoDaddy, and on. There's hundreds of them. Okay, their focus is really the web. Okay, so websites. You go to www.ibm.com. IBM has gone to one of these, in this case, DigiCert, to get a certificate. Okay, There's also, these are generally fee-based, right? You have to pay them a fee for them to do that work. There is software, though, for enterprises to run their own certificate authority internally, right? There's not a lot of need for them to go external. For a database server to get a certificate, you can manage that in-house. So many big enterprises will have their own security teams act as a certificate authority. And there's various software packages out there to implement that. We won't get into the details, but a couple of them are listed here. Okay, so just remember, certificate authority, their job is to issue certificates after they have validated the identity of who they're giving it to. So how do I indicate I trust someone? So great, okay, there's this company DigiCert, and Greg's saying they're trustworthy, and what do I do with that information? So you add their public key in the form of a certificate into a trust store. So this is a specific key store that's holding trusted root certificates. You're basically saying everything in this file is what I trust. These are who I trust to sign things, okay? In the case of the internet on the web, a combination of your operating system and your web browser maintains a list of hundreds of trusted root and intermediate certificates. So if you start digging into Firefox or you start digging into Windows, that sort of thing, you can find, here's the list of all the certificates that are trusted by those products, okay? For DB2, we're going to be manually adding certificates to a key store that we create. We don't have that list of hundreds that are maintained automatically for you. We're going to be doing the steps to do that. And typically it's because on the web, it's very important for you to have a website that has a certificate that the end user's browser's going to already support, right? You don't want to have the user to do anything to get to your website to make it work. Whereas the case for databases deep behind the firewall, you're likely using an enterprise CA that won't necessarily be trusted by the browser. You don't need all of those other root CAs trusted. You just need the one specific one for your use case. And so that's why we're going to set up everything manually for DB2. This is just a little picture of what things look like in use. So there's two parts. There's the setup on the left and an actual connection on the right. On the very left, the client will first download the root CA certificate, okay? Again, these are public things. If you're using a public CA, you just go to the website and download it. Otherwise, you'll contact your security team. They'll say, here is our root CA certificate. And you're gonna configure that on the client. The server is going to do the same thing. It's going to get that root CA certificate, but then it's going to go back to the CA and say, can you sign a certificate for me saying who I am? And they'll go, okay, yeah, sure. Your security team will say, yes, here's your certificate, give it back to you. Then during the connection, the client will connect to the database or to the website or whatever. The server, as part of that connection handshake, will send back its certificate. At which point the client will then validate it. It's going to look and say, oh, this certificate was signed by X, and I trust X because it's in my trust store. I have a key store set up with the root CA certificate that I said explicitly, I trust anything signed by this root CA. So then the client goes, great, it matches, and now I can use that to establish the SSL connection. There's more details to that. The client will use that certificate and the public key to generate a session key, and it will encrypt that session key with the public key inside the certificate. And if we go back to the fundamental principles of SSL, only the private key that corresponds with that can decrypt it. And that's private, so only the server will have it. Nobody else has the private key. And so now we're establishing an encrypted session between the client and the server because only the server can decrypt that session key. Okay, so that's kind of the basic fundamental principles that we need to understand about certificates before we can figure out now how does DB2 make use of all this. Okay, good news is that TLS, SSL, is seeing widespread adoption in DB2. We've had it in client and server for a while, and that's over our DRDA protocol, but it's also in a number of other places that people might not be aware of. Recently, HADR, between primary and standby, supports SSL as well. There's some backup slides that are going to talk about all of these and their configuration. Today, we're just going to go through the client-server portion of the configuration, but once you really understand the basics, it's easy to apply that to other scenarios. Federation for outbound connects to a data source. For DRDA and ODBC wrappers will support SSL. KMIP, native encryption key managers for DB2. Those are all supporting SSL or TLS. And LDAP, if you're using our LDAP authentication plugins, there's options there to configure TLS to encrypt the traffic to the LDAP server as well. So it's great. DB2 is really adopting TLS in the database. There's a couple of things just to be aware of. Right now, TLS is not supported between members in DPF or PureScale. Typically in those scenarios, you're on sort of a private network, deep in the enterprise, that you're not exposed to sort of a public type network where encryption is absolutely required. If you had to have it right now, our suggestion would be to look at something like IPsec at the operating system layer to encrypt those communication channels. And the other thing just to be aware of is data encrypt. This has been deprecated in 11.5. It is a proprietary encryption mechanism between client and server for use with DRDA. It uses an old algorithm, DES, which is not secure by today's standard. It was at the time we developed it, but we haven't kept it up to date because TLS has really established itself as the industry standard for encryption on the network. So if you're using data encrypt, I strongly suggest that you switch over to TLS. So how does DB2 use TLS? It's a really complicated protocol. We've only touched on sort of the very highest level of it, and it's got a lot of optional features. Specifically, we use TLS for encryption of data over the network. Okay, so just between client and the server, that the data will be encrypted in a strong manner. The client supports certificate authentication against DB2 for Z. This is a feature that they have that DB2 for LUW does not currently support. So you might see that in some of our documentation about certificate authentication, but for DB2 LUW, it's not supported right now. And just some other things to be aware of, that there's some optional features that we do not support. So server hostname validation, this is giving you an additional authentication mechanism from TLS. We do not currently do that. And we don't support certificate revocation or pre-shared keys. So just something to be aware of. So how do I manage the use of TLS? So I said the good news is it's everywhere. Well, the bad news is it's everywhere. And that each of those places we use TLS is largely managed independently and configured separately. So there is a bit of work to get it, to turn it on in all of those places. Okay, but the one unifying aspect that we're going to talk about here is that they all require a key store to store certificates. And what is that? It's a file on disk, and it's a file that contains certificates, private keys, and secret keys for native encryption, although we won't really go into that detail today. So that's a big part that gets a lot of people confused, is what is this key store and what do I have to do with it? Not helping that problem is that there are many types of key stores and many files supported. So some of the ones to be aware of, a .kdb file, if you've seen that, is an IBM GSKit proprietary key store file. There's a P12 file, which is an industry standard format for storing cryptographic objects. There's a JKS Java key store. I think it's similar to a P12 file. Those are sort of the main, so almost like databases that can store multiple certificates. P12 would be my recommendation if anyone's looking for what to use. We have a couple of others to talk about. There is a base64 ASCII encoding of a certificate, and I have an example in a later slide. They come in many different extensions on the file, .pem, .csr, arm, .cer, CRT. They generally all look like the same thing in that they're just an encoding of a certificate, a single certificate. Our clients and our server as well support Microsoft Certificate Store. So this is the operating system has a certificate store that DB2 can interact with. And there's a very special case, I just mentioned it here to let people know, for the ZOS authentication, the DB2 drivers do support a smart card interface for their certificates, but not against LUW. So if you see that in the docs, that's what it's referring to. All of these files, like a P12 file or a KDB file, are cross-platform, so they can be copied from one system to another. And this is just a little chart that says, okay, of all the places DB2 uses TLS, which type of key store can I use in those cases? What is supported? So it's you kind of got to look, okay, I want to do client-server communication. So at the server, here are the various key stores supported. If I'm using a Java client, what type is it? HADR only supports a certain type between the servers. A lot of it comes down to, is it C code versus Java code that is accessing the key store. Now, the key stores we talked about, like a P12 file or a KDB file, are used for sort of storing them permanently on disk. There's also some common formats that are used for transforming or transferring certificates between maybe your security team and the DBAs. P12 is great because it fully encrypts it with a password. The PEM file, privacy enhanced mail, .pem, ARM, all of those usually just have maybe a certificate, sometimes a private key in them. And this is what they look like. You'll often recognize them with the very beginning of the file will say begin certificate, and then you'll have a whole bunch of ASCII characters and then end certificate. And that is the base64 encoding of the certificate. There's another format, PKCS7, and it often has a .P7B or P7S extension. It is very similar to the PEM format, but you'll see a begin PKCS7 and end PKS7 around the file. And both of these are supported by our GSKit tool for creating key stores. So we've kind of talked about there's the different types, P12, KDB. How do we get them? How do we create them? Well, your security team might just give it to you. We have a GSKit tool, command line tool that will create them. There's something called Keyman, which DB2 does not ship, but is out there. It's a Java version. Java itself has a tool called KeyTool that can do it. Or don't even create one. There's a couple of options where you don't even need a key store. Simplified SSL setup, which we'll talk about, or just use the Windows certificate store if you're on Windows. So how do you get these things from your security team? We certainly have customers we've seen where their enterprise team will just give them everything. Okay, they'll say, here's your P12 file. Or they'll say, yeah, that's the normal option. It helps the DBA in that they're kind of given everything, but once you start dealing with expired certificates and you're having to do more importing, you're still gonna have to learn these steps. So it seems like it's an easy first setup, but sometimes it becomes harder down the road when your security team gives you everything and then you're not sure how to integrate the two. Because the key store will store both old and new certificates. You've heard me talk a little bit about GSKit. That's IBM's global security kit. It's a command line tool and an SSL library that most IBM products use for managing encryption. In this case, we'll be using the tool to create, alter, import, export certificates from a key store file. So we ship it with the DB2 server. The client includes enough of GSKit to use SSL. It's only lacking the command line tool, for which case you can download GSKit from Passport Advantage and install the full product. If you have an existing key store that you're copied amongst your clients, then you don't need any extra installation. What comes with the drivers is enough to use SSL. This is just an example of how you would create a key store. So the keydb create command, give it the file name, and it's going to create it. You're going to give it a password and optionally stash the password in a file. And that's called the stash file. And what that is it's an obfuscated, that's a tough word to say, an obfuscated form of a password in a file. So it's protected by file permissions for the instance owner, and it allows DB2 to access that key store without you having to type in any additional passwords. So nobody can go to that file and read it, but it just allows DB2 programmatically to go open the key store file. So at the server, somewhere in the instance owner's home directory is usually a good location for storing your Keystore files. So what do I need in my Keystore file? Again, depending on where you're using TLS within DB2, the main thing to remember, anything acting as a client requires the root CA certificate, okay? Because that's what we're saying we're going to trust to sign things. The server needs the root and any intermediates, plus it needs its server endpoint certificate. So it went off to the root, the CA, and said, can you give me a certificate? And you got it back. The server needs that, but the client doesn't need to be told that, right? It just needs to be told the root CA certificate, and that's who it's trusting. And then when it sees the server cert, it validates that it was signed by that root and goes, oh, okay, I trust this now. So you can look back for the other use cases, but we're going to focus right now on the client and the server. So the next step then, okay, so you've created your Keystore file, you have it available. Now you need to get a certificate. So you're at the server, what do? Well, there's sort of three options. The most popular one, I think we saw from our poll, was you will generate a certificate signing request. This is a specific format of a file that you give to the CA saying, please sign it. They'll validate that information and give you back an actual certificate, which you will then add to your Keystore. The second option is some enterprise CAs will generate everything for you. They'll say, here you go, here's a public key, here's a private key, here's your signed certificate, all in one file, and you then import it. The benefit of the first option of a CSR is the private key stays private in your Keystore. It never leaves the confines of the Keystore, only the public key does. In the second option, your CA is giving you everything. So technically they know what the private key is. So, the server will know the private key, and typically you'll trust your enterprise security team, but they will have a copy of the private key as well. The third option, and I think it was higher than I expected on our poll, was people using what are called self-signed certificates, okay? It's a bit of a chicken and egg thing because you don't have a root CA in this scenario. You're signing your own certificate. So who came first, the signer, the issuer? There's just basically a special way of saying, I'm issuing a certificate to myself. So if you go look at the certificate, the issued for and issued by will be exactly the same, okay? It's great because there's commands in GSKit to do it. You don't have to go talk to anybody, okay? And there's backup slides that will show you the exact command to do it. But the downside is that we're really back to that problem of key distribution, right? So I now have to go to every single client and say, for this server, here is its self-signed certificate. Can you please trust it? Okay. If you have 100 servers, you're now doing that 100 times for each server. So 100 times you have to go to every client and say, here's the certificate. You have 1,000 clients. This suddenly starts to add up to be a problem, right? So typically self-signed certificates are used for small deployments. So maybe you have a database server, but it's only used by a single application server or a small set of application servers. You're not transferring it out to thousands of clients. It's only 5 or 6, something like that. Then it can make sense, right? It's not an onerous task to distribute the certificates to the clients. So we now get into some technical details about, okay, for those various scenarios, how do I actually do this, right? So this is how do I import a root certificate into my Keystore? I've downloaded it, what do I do with it now? Well, there's a cert-add command for GSKit copy command that says, trust this as my root CA certificate. So cert-add is basically saying trust it. It's adding it into the Keystore. So the next option we talked about was, generating a CSR, right? I want to give something to my CA to sign it for me. So in this case, there's a certificate request create command. And then you give it a number of options, particularly your distinguished name, right? You can ask for a specific size of key, and then the output goes into a CSR. So the CSR file is what you send to your certificate authority. It will sign it and give you back a certificate, okay? As part of this, it creates the public and private keys, and the private keys are saved away. GSKit remembers that there's a certificate request for that private key, and then you're going to, in the next step here, add that back in. Now you don't use the add command for a CSR. Okay, add means make this a trusted CA certificate. We don't want that. We want to match up the certificate with our CSR request, with the private key. And it is the receive option that does that. This is a problem we see time and again that customers mistake is they get back the certificate and then they do an add. You have to do a receive so that it matches up that certificate with the private key that was created during the CSR request generation. Okay, so add is for root CAs, receive is for the certificate to match the CSR request. So that's a really important thing to know. But once you've done this, you will now have a certificate and matching private key. And if we go back a slide, it will have the label DB2 server. So that's just like the friendly name for the certificate. So there's no label option on this command because we already gave it when we generated the CSR. Okay, you may have your enterprise, your security team give you both a root certificate and an endpoint certificate all at once. You can import them. So you don't add, you don't receive. This is when you just have the certificate and a root and you want to put it in. You do an import, okay? So the order is important. The private key must appear after its certificate. So typically this file, the certs.pem file will have three things. It'll have a root CA certificate. It'll have your generated certificate for the server as well as its private key. So all three things will be in one file. And in this case, you do an import, okay? You're not doing an add. We're not doing a receive because we did not generate a CSR in this case. The security team has just given us everything. So we have to do an import, and that will bring everything together. Couple of important points to note about that is that importing multiple items was broken prior to these fix packs. Okay, 10.5 fix pack 10 and 11.1 mod 3 fix pack 3. Okay, there's an APAR for that. So you need to be using a release after that to import everything all in one command. One of the downsides is that you can't label, like if you have both the root CA certificate and your server certificate, you can't label them on import. They're going to be given, the distinguished name will become the label. But there is an option where you can just rename them if you want a more friendly name to them. If you only had a single certain private key, your root CA was separate, then you can give it a label because there's only one thing on the import that is getting labeled. So after all this, how do I know I did it right? There is a cert list command that will list the contents of your certificate, of your Keystore file. In this case here, we can see that we have two. We have a my root CA, which with the exclamation mark is a trusted certificate. And we have a DB2 server, which is a personal or endpoint certificate. So this is how we want it to look. We want to trust our CA certificates, and the certificates for the server have to have a dash, okay? If they have an exclamation mark, it means you've probably done an add instead of either the import or the receive, depending on your situation, okay? And then how do I find out the details of my certificate? There's a cert details command. You give it a label and it'll tell you what the key size is, who issued it, what the expiry date is, and there's like a big screen that gets printed out, but those are the most important, particularly the not after. When does it expire? Okay, we've gone through all the locations within DB2 where TLS may be used. We've talked about keystore file types and how to get certificates. Now we want to quickly go through how do you configure DB2 to use TLS. So it's basically a bunch of DBM config options to start with. So at the server, there is, how many do we have here? 2, 4, 6. We want to tell DB2 where is the full path to your keystore file, okay, that has both the trusted root and your server certificate. What's the full path to the stash file? What is the label inside that keystore that represents what the server is going to use? You can have many certificates in there. Which one is the server using? Which version of TLS should we be using? And remember, you should always configure TLS v12 here. The default is TLS v1, which you do not want to use, okay? You tell us a port. Just like TCP/IP, there's a service name port. Well, there's an SSL service name port as well. What port should we be listening to for TLS connections? There's no standard. Customers often use 50,001 because they've used 50,000 for the service name. My recommendation, though, is don't use 443. Okay, that's reserved for HTTPS websites, and you'll have network scanners that are looking on your network in your enterprise, looking for like vulnerable websites, that sort of thing, security scans, and you'll just have your dialog fill up with all of these messages saying, you know, bad connections and that sort of stuff, because they're targeting 443. So you don't want to use that. There's another parameter called cipher specs. The backup material has some details on it. Generally, you want to leave it blank, but there's specific cases where you can limit which type of ciphers are used. Once you've set those DBM config values, you set DB2COM to SSL. Optionally, TCP/IP as well. DB2 supports using both protocols at the same time. And then you have to restart the instance. And there's going to be more on that later, because I know that I just sort of heard groans across the internet saying you had to do a DB2 stop and a DB2 start. And we'll talk about that in a further slide. So that's the configuration at the server, okay? That's all you need to do once you have your keystore set up. At the client, it depends on what type of client you're using. So instance-based clients, you're familiar with the catalog TCP/IP node, a command, you just add on security SSL to tell us to use SSL, and then you update the DBM config to tell us where your keystore and stash file are. And just remember, this keystore file is the one that has the root CA in it. It doesn't need the server certificate. It is just the root CA certificate that you trust to have signed the server cert. If you're using the data server driver clients, so not an instance-based client, then in either the db2cli.ini or db2dsdriver.config, you add an option saying that the connection should use SSL. And then there's also parameters to tell us, again, the same thing as before, where is the keystore file and where is the stash file. Java clients, very similar. There's a property that you say use SSL connection is true for this. By default, Java has an existing SSL trust store that you can add your certificates to, like the root CA certificate. And optionally, there are other parameters that you can override where that trust store is, where to find it. Java has a special requirements for a security provider, and you can refer to our documentation for a little more details on how to set that up. I want to mention simplified SSL setup. So this is something new in 10.5 Fix Pack 5, where clients do not need a full keystore file. Instead, you can give us the root CA certificate in a PEM format file. So a .cer or CRT or something like that. Basically, that's the base64 encoded version of the file. So you don't need to set up a keystore. You can just say, oh, I downloaded my root CA certificate. Here it is, and then tell the driver about it, okay? So there's an SSL server certificate keyword for CLI and an SSL cert location for Java that basically you just give it the path to that file, the fully qualified path to that file, and we will just use that. So it saves the clients some setup steps. And now we took it even further for connecting to DB2 Warehouse on cloud. Okay, so in the cloud, our DB2 instances are have certificates signed by DigiCert. Okay, so it's a public CA that has signed these, and we actually ship as part of the driver the DigiCert root CA certificate. So you just need to tell us, hey, use SSL, and everything else works. Okay, it's really that simple. That's why we called it the simplified SSL setup, because we know to go look for that DigiCert root CA and use it. You don't have to tell us where that file is. It's part of the installation, and it's actually there in the default Java Trust Store as well. So it's really easy. Use SSL, and when you're connecting to DB2 Warehouse on cloud, it will just work. Okay, so getting down to the last few slides is just some of the operational aspects of working with certificates. Okay, so we've seen how to configure DB2. And yeah, I just should mention again that for things like HADR, LDAP, the additional slides at the end that you'll have access to have the detailed for those configurations. And they're very, very similar to what we've just seen. Okay, expiring certificates. I promised to talk a little bit about this. Your certificates do expire depending on your security team. Often it's like a 1 to 2 year lifespan for your endpoint certificates. Root CA certificates are on the order of maybe 20 to 30 years, but for your server certificate, it may be like a year, and it's very similar to like your password having to change it. You're going to have to get a new certificate. So it's called renewing a certificate, but it's really nothing more than generating a new one. Okay, there's no specific renew command. You just go through the same steps you did before to get a certificate. You're just going to get a new one. Now, the key stores, like a P12 file or KDB file, can hold multiple certificates. It's not a single thing. So while your system is running, you're going to go off, work with your security team to get a new certificate, add it in with the steps we've shown. You know, if you're using a CA signed certificate, then the only change is at the server. The client should already have that root CA certificate. If you're using self-signed though, you're going to need to distribute the certificate to all of your clients, okay? You update the DBM config to give it the new label, and you're going to have to do an instance restart again, okay? You have to do a DB2 stop, update the label to the new certificate, and do a DB2 start. HADR is a special case. You just need to deactivate and activate the database at the standby to break the connection. You don't actually need to stop the primary. Now, like I said before, I can hear the groans that, you know, this is a lot of frustration having to do an instance outage every year or whenever they expire. We've heard it loud and clear from a lot of people. We're looking at fixing it. I can't comment to on or when it might happen, but it's definitely something we are very, very aware of. How do I know when my certificates will expire, right? So you got to plan for that. A lot of cases, your security team will warn you. If they were the ones that gave you the certificate, they generally track these things and will tell you, oh, by the way, in a month, it's going to expire. You might want to keep track yourself because that 1 month notice might not be enough to plan that downtime. Right now, there's no SQL interface to check the expiry date, but there's 2 ways you can do it. Locally, you can run the GSKit copy command to check the details and look for this not after flag, which will tell you when it expires. You can use OpenSSL command line tool remotely to query the certificates. Okay, so the S client option basically establishes an SSL handshake, right? So you would put in your server, DB2 server hostname, and the SSL port, and it'll print out the certificate that it exchanged as part of the SSL handshake. You know, OpenSSL can't speak DRDA, it's not going to connect to the database, but it can set up that initial SSL connection and then drop it basically. But it'll print the certificate, and it'll print the not before and not after dates. So you can check expiry dates remotely. Have a simple script or something that goes to all of your databases and you can find out when your certificates expire. Performance of SSL or TLS. In general use, it has little performance overhead. Every setup is different. As soon as you say the word performance, the answer is always it depends. The biggest impact is there are extra flows to establish a connection. Okay, so when that initial TCP/IP connection is established, there's a few extra back and forths that happen. If you have really, really short connections, they're going to show a higher latency, right? Because that's going to be a significant portion of what those short connections do is setting up that SSL connection. Once the connections are there, the encryption does have increased CPU usage, but it hasn't shown to be a very significant factor. Hardware acceleration really does help. So on modern Intel CPUs or Power 8 and above, there's a blog here that you can check out about which platforms support it and how to check if yours does. And a very special note, if you're on AIX, there's a tech note that you really want to read about some malloc settings that can greatly impact the performance of SSL. So monitoring, there's two ways to check if a connection is using TLS. So mon get connection, there is a client protocol column which will tell you, or db2pd-applications. If you run that at the server, an encryption level of high means that TLS is being used. However, it's not possible to determine from those whether TLS version 1.1 or 1.2 was chosen. Okay, now hopefully you've taken my advice, you've configured it so that only TLS 1.2 is being used, right? So then there's no question about it because you've only configured the one. But if you have multiple ones and you're trying to track down which connection is using it, unfortunately there's not an interface to show that. The Keystore, backing it up, this is a file that's sort of considered to be external to the database server, and it's your responsibility to back up the contents, okay, of the Keystore file and the stash file. It's a good idea to keep them track of the password as well, instead of just the stash file. In case it gets corrupted or something, you can regenerate a stash file if you know the password. So it's good to sort of know for this Keystore file, this was the password that we were using. It's not always the end of the world when you're talking about TLS. If your Keystore file gets corrupted or something, you can always regenerate these certificates. You can go back to your CA and say, oh, I've got a new CSR. Can you create a new certificate for me so I can get back up and running? Or self-signed certificates, you just regenerate them, but you're just looking at a downtime, right? So, maybe it's on a Saturday and your security team's not going to see your requests till the Monday. And now you've got the whole weekend that your database is out of business. So you really want to have these backed up so that if something happens to it, someone accidentally deletes them, that you could put it back in place right away. The only caveat to that is that if you're using, the Keystore files can also store the secret keys for native encryption. And in those cases, it's absolutely critical that you have those files backed up. You cannot recreate secret keys like you can certificates, okay? And if you lose those secret keys, you risk losing all of your data because that is required to decrypt it. So if you're using your Keystore file for both SSL and native encryption, you have to make sure it's backed up. That's absolutely critical. DPF and PureScale and HADR, just some special notes. The same label will be used on each member for DPF and PureScale from the DBM config. You can have a shared Keystore file, or you can make it independent. Both scenarios will work. Think about availability issues if you're using a single file, especially for HADR. That may not be the best choice. You can use the same certificate on each machine, say for a DPF cluster, or it is possible to have one different, but their labels will be the same. So you would have to have individual Keystore files in that case, okay? The CF for PureScale does not need a key store. Sorry, does not need a certificate. There's not an SSL connection from a client going to the CF. And then we're on to the last few slides, just a couple about problem determination, because we do get a lot of questions about setup issues, although hopefully people can now watch this and get through them. Most problems are setup problems when you get SSL errors. You'll see GSKit errors. Some examples you'll see are SSL socket setup, such as the 420, or on the dialog at the server, you'll see a secure socket init function with a 402. And there'll be different numbers there, okay? Different types of errors. This website has a list of them, but I've gone over just a very few of them that we have. So 420 at the client means the server's closed the connection for some reason. There was something it didn't like about the certificate, and TLS basically says the server's supposed to immediately drop the connection if it finds something it doesn't like. So you have to go to the server to see what was the reason. And usually there'll be something in the dialog that'll indicate what it didn't like. A 407 error, the label can't be found in the key store. So check for typos. When you told us in the DBM config what the label is, did you put it there? Don't put quotes on that in the DBM config. Maybe you put quotes around it on the shell, but you don't want those extra quotes showing up in the DBM config. Look at the contents of your key store, right? The cert-list option. Make sure your server certificate has a dash, meaning it's personal, and not an exclamation mark, meaning it's trusted. I think I mentioned that before. This is the biggest error that we see. People have done a cert-add instead of a cert-receive on the certificate, and it ends up in the wrong state. Couple more. 402, no ciphers. Often this is a client that is not at a fixed pack supporting TLS 1.2. So you have a 10.1 GA client connecting to a recent server. It doesn't support TLS 1.2. You can get this message at the server in the dialog. Bad key file password. There's something with the stash file that it's wrong. The password isn't correct. And error bad message means you're not connecting to an SSL port. Or there may be something in the middle like a firewall that is interrupting the data. It's basically saying the client and the server were not exchanging proper SSL setup information. So you'll get that bad message error. And that's it. So Martin, we've flew through everything there is, and there's now, I think, 40 some slides for homework for everybody. But as far as what we're gonna talk about today, that is everything.
Great. I just had a question, comment, if I may.
Sure.
One of the things we learned with going through an encrypted database ourselves was doing a redirected restore. Means that you also have to move the key store to the new to move the key store as well as the database to a new server. Let's say, for example, I lose a server and I need to do a recovery to a new server. I not only have to have a backup, but I also have to have the key store, don't
I? You could, yes, have the key store file that you would copy over there. It would be just as possible to recreate and have a new certificate, maybe even in place before you had to do that restore, at the new server as well, right? Yeah. So you could generate a brand new one there, have it signed, and then the clients wouldn't have to change because you're having the same root CA sign it. They're already going to trust it immediately.
Yes, but if the database itself is encrypted, if you don't have a way of having that database available and being able to be decrypted.
Okay, so if you're talking about native encryption now, right? So the encryption of the data on disk, then absolutely you're going to have those keys available to you on the new server in order to decrypt that data.
Right.
Well, it'll really be about decrypting the backup, right? So you're doing a restore, your backup was encrypted, you need the keys to decrypt that backup.
Right.
But for SSL, it's all about that in transit. So you're transiting to different servers, they can have their own certificates.
Yeah, that's great, thanks. My experience is that you want to test this stuff before you have a production problem.
Oh, yes, yep.
All right.
Absolutely.
That's actually fantastic. I found your explanations extremely clear, and I think the audience will find this, and the people that download our replay and listen to it on YouTube will find this presentation excellent. So I have one last question before I let all you fine folks go, which is our famous last question, which is, did you learn something today? Let me launch that now.
I don't get to vote in these, right? And skew the results.
Did you learn something by presenting today? You learned something about GoToWebinar?
Yeah, exactly. All
right. I'm going to close this off because the results are great, and I think people want to get on with their lives. And 100% of the audience learned something today. We get that number.
Oh, that's perfect.
Fairly, and we don't get it all the time, and it's absolutely fantastic when we do. So that's absolutely great. With that, I'm going to take over control here. We have the power. You have the power. There we are. I'll take my screen back, and we will just go through and do our last bit of, oh, we don't have a commercial today. Look at that. We normally, on the DB2LUW show, we like to show off the DBI tools, but we, this time around, we don't have that ready. However, if you do fill out your ending after the show survey, there's a question there that we will be giving out a gift card for those people that fill out the survey and are able to receive a gift certificate. I think it's a $10 or $15 certificate. Please do that. I'd like to thank you, Greg, for doing such a fantastic job. And
you're very welcome. You're very welcome.
I hope you were able to come back and join us again as content and your time allows. And thanks to everyone in the audience for attending. Let me cue up the music here and wish everybody a great rest of the day. And we will see you next time on the DB2 Night Show.
Great. Thank you very much, Martin. Thanks for everybody for listening.
Thank you, Greg. You all have a good weekend. Enjoy what's left of our summer up here in the Northern Hemisphere, or winter down in the south. Take care. We'll see you next time on the DB2 Night Show. Bye-bye.